Okay, so we struggled a little bit about on this 8.2, 8.3 practice test, but that's just part of life. Struggles are part of life, and we just got to get over this hurdle and move on with our life. We just got to get back up, brush ourselves off. And so I'm going to go over some of these problems, and hopefully this will help you have a better idea of where you went wrong on this practice test that you just took. So starting off, number one, identify the vertical asymptotes of this. Well, to identify the vertical asymptotes, what you really need to do, you got to take this bottom and you got to set it equal to 0. So I'm going to take this x squared minus x minus 12 and set it equal to 0. But when you look at it, you can't solve it just like that. You got to factor this left side. So I'm going to do my little x thing over here. I'm going to figure out what times what is negative 12. That adds together to be negative 1. And it turns out to be 4 and 3, but the 4 is the negative. So I have x minus 4, and I have x plus 3 equals 0. That's from the negative 4 and 3 right there and there. So now I got to ask myself, what do I have to put in for my x to make it equal to 0? Well, to make this right here, this equal to 0, if I put in a negative 4, that doesn't do it, that gives me negative 8. But if I put a positive 4 in there, this becomes 0. And 0 times this will also be 0. Therefore, one of my solutions is when x is equal to 4. That will give me one of my vertical asymptotes. Okay? And then my other vertical asymptote is that when this becomes 0, how do I make this x plus 3 equal to 0? Well, I have to make my x equal to negative 3. So my other vertical asymptote would be the equation x equals negative 3. And these are my two vertical asymptotes. Now remember, you're supposed to cancel top to bottom if there's anything. This one, there's nothing on bottom to cancel with this 2x squared on top. Nothing cancels out. So my vertical asymptotes are x equals 4 and x equals negative 3. Let's see if that's on here. Yep, this one right here. Check that. And moving on. Oh, good. Got that one right. Okay. The vertical asymptotes for this one. So again, we're going to factor it. But remember, if something cancels, that creates a hole, not a vertical asymptote. So let's factor this bottom, factor the top. See what we get. Well, the top's already factored, so we have x plus 2 on top. This bottom, we're going to make a little x thing over here. We'll put the 6 on the bottom. We'll put this 5 that goes on top. So what times what is 6? That adds together to be 5. We got 2 and 3, so we have x plus 2. X plus 3. Notice the x plus 2's cancel out. So these two right here create holes. One hole. That creates a hole when x is equal to negative 2. Not a vertical asymptote. It's this right here, the x plus 3, that makes a vertical asymptote. How do you make this a vertical asymptote? What do you have to put in for this x to make it equal to 0? Well, you have to put a negative 3 in there. So we have x equals negative 3 is where we have a vertical asymptote for that equation. So you're going to see two on the test just like this. And this one and the previous one. And one's going to have a hole on it, and so that's going to take one away from the vertical asymptotes. So make sure you keep your eyes open for that. Okay? Keep your eyes open for that. Moving on down. Match the function with this graph. Okay. Well, let's just kind of get down here and see these equations that I have right here. There we go. That's pretty good. Okay, so we need to match this rational expression or rational function with the graph. But what I'm going to do is I'm going to put in where it looks like I have my asymptotes. So it looks like there's an asymptote right here, and that goes through 1, 2, 3. So I have a vertical asymptote when x is equal to negative 3. Okay, and then let's find a horizontal asymptote. I got a horizontal asymptote probably around, somewhere around here. And that looks like it's the equation y equals 2 for the horizontal asymptote. So let's see if we can use this to figure out which equation down here it is. Well, the vertical asymptote is x equals negative 3. So this negative 3, if you put in for the x, the bottom becomes 0. If you put negative 3 in for this one, the bottom becomes negative 6, so that's not right. And it doesn't work for that one or that one. So this is the only possible solution right here. G of x is equal to 2x. And if you put a negative 3 in for this x, negative 3 plus 3 is 0. So there you go. Notice that the horizontal asymptote, we have that 2 right there, so that would give us that. But that's the only possible answer that it could be. So I'll check that one. Delete it. Yeah, delete. There we go. Sorry about my voice, everyone. Just kind of losing it a little bit. Might hack a little bit during this whole video, so just beware. It might come out when you're least expecting it. Okay, so here, we're going on the next one. We want to simplify the rational function here. Enter your answer using parentheses as follows. The parentheses are on the top and the bottom. I might not have those all in this practice test, but they will be in on the real deal. So let's first figure out what the top turns into. I'm going to use this little method because I have x squared minus x minus 42. Put my negative 42 there, and negative x there. I know this is 7 is 6, and this is the negative. So on top I have x minus 7, x plus 6. That was my top right there. And now let's factor that bottom. Okay, now notice I got my negative 49, that goes on the bottom, but what do I put on top here? What do I put on top? Well, there is really, you could add a 0x into this, and then what goes up here is a 0. So you got to ask yourself, what times what is negative 49? I got to be 0. Well, that's 7 and negative 7. So that will be my bottom. So I have x minus 7. I got x plus 7 from that. Now what can I cancel out? Well, I can cancel out this factor right there with that factor right there. And what I'm left with is just right here, x plus 6 over x plus 7. So let's get that entered in there. X plus 6 divided by x plus 7. Oh, good, let's check that. Excuse me, everyone. Okay, that was good. Okay, moving on to this one. Okay, when I do a problem like this right here, I like to focus on certain features or things at once. So first what I'm going to do is I'm going to focus on all these x terms, because everything is just being multiplied or divided. So we're going to focus on all the x terms, and if you notice I got 3 x's here and 3 x's here on top, so all together on top I have x to the 6th power, and all together on bottom I just have x to the 5th power. So if I cancel 5 x's on bottom, how many x's am I left with? 1, and it's on top. Okay, so really my fraction bar will have an x left over on top. Okay, so that's taking care of all these x's. Let's get rid of them all. Okay, so now I'm just dealing with all these numbers, and there's different ways about doing this. You could do 14 times negative 9 times negative 6, and then you could do 27 times 2 times 3, and then you could divide the 2, put it in your calculator, use the fraction thing, have it simplified down. That's one way to do it. Let's do the harder way. Let's think through this. First, 2 negatives, when you multiply it, become a positive, so I'm just going to make those 2 negatives positives, so we can ignore those. I see this 9 right here, and I see the 6, and I know that 6 is really 3 times 2, and 3 times 9 is actually 27, so these two cancel this 27 out right there, and so I'm just left with the 2 there, with that one. Okay, oh, look at this 2. That 2 cancels out this 2 right here, so that's gone. And then we took care of the 6 right there earlier. So really what I have is 14 divided by 3. I don't think 14 and 3 cancel each other out anyway, so I got 14x over 3. Let's see if that turns out to be the right case. 14x divided by 3. Checking it. Click and check again. I'll do it one more time. There we go. 14x divided by 3. That turned out perfect. Oh, here we go. This is going to be a tough one. Okay, I'm going to do this in little parts. I'm going to do this part, and then I'm going to do this part, and then I'm going to do this part, and then I'm going to do this part. I'm going to factor each part, and I'm actually going to do a little flipping too, because remember, when you divide a fraction, what you can do is you can make multiplication, but then you have to flop these 2 fractions right there. So let's factor each of these parts. We'll first start with this part. We have x squared minus 36. I know that is x plus 6, x minus 6, and if you use this little x thing to do that, you put the negative 36 on the bottom and the 0 goes on top. So you have 6 and negative 6. Let's get through that one. Okay. Now I'm going to do this red section right here. I look at these 2 and I ask myself, is there anything I can factor out of both of these that's in common? And you bet you can. Look at these, both have an x in it, so I'm going to factor an x out of there. I'm going to factor an x. When I do that, I'm left with just an x here. I'm left with just 6 there, so plus 6. So my bottom, my red is x times x plus 6. Okay. Now I'm going to go do my blue. Okay, but I'm going to do multiplication now instead, and so this blue I'm going to put on the top right up here instead, because I'm flipping it and multiplying instead. So I look at both these 2 things and I notice that both of them have x's, so I'm going to factor out an x squared because there's an x squared in common. And then what's left in this term? Well, this term has an x left, and this term right here has a plus 4 left. So that's what that factors to be. So we have x squared, x plus 4 right there. And now let's do my green. The green's going to go on the bottom. We'll do a little x thing right up here. Negative 12 goes there. Negative 4. I think it's 6 and 2 gives us negative 12. But which one's negative? There, we got the negative. It's the 6 because you add together it'd be negative 4. So we got x minus 6 and then x plus 2. Okay, so now all is said and done. Now it's time to cancel some things out. So we got this x plus 6 cancels off this x plus 6. We got this x minus 6 cancels off that x minus 6. We have this x cancels off one of these x's up here. So I'm just going to get rid of the square. Okay, and what do I have left? I have x times x plus 4 all over x plus 2. That's my final solution. So I'll type that in if I did this right. X times x plus 4 divided by x plus 2. Boom. X times x plus 4 divided by x plus 2. Checking it. Fingers crossed. Oh, we're doing well. We are doing well on this one. Okay, moving on to this one. Same idea. This one's actually maybe a little bit easier because I don't have to do the flipping of this. So we're just going to factor each of these sections. Here's my blue section. I'll factor that one blue. This will be my green section. I'll factor this one as red, and I'll factor this one as black. Okay, so we'll start with my blue section over here. I have x squared minus 9. That is x plus 3, x minus 3 right there. So that's the blue section. And we got the x squared plus 2x minus 8. So what times what is negative 8? They add together to be 2. 4 and 2. So we have x plus 4, because we need the positive 4, and minus 2. It's minus 2 for that one. And there we go. And then we're looking at this one. There's a greatest common factor here and here. I can factor that x out. And then I'm left with an x minus 3. So that's my black section right there. X times x minus 3. And finally my red section. Let's make my little x here, put my 20 on the bottom, put my 9 on top. Oh, that's 5 and 4. Oh, that's nice. Okay. X plus 5, x plus 4. Here we go. So now let's start canceling top and bottom. X minus 3, x minus 3 right here cancels that one. And then x plus 4 cancels off that x plus 4. There we go. That's all you can cancel. So on top I'm left with this x plus 3 and this x plus 5. The bottom I'm left with x minus 2 and x. So some of you maybe put this in right, and I just didn't have all the different ways that people could enter these in. So I apologize for that. That will not be the case on the actual test. The actual test will have all the different ways in. Okay. So we divide that by x minus 2, and then times x. X plus 3, x plus 5, x minus 2, and x. Checking that. Fingers crossed, everyone. Fingers crossed. Is Moodle down? Is that why this isn't working? Because Moodle's down. That's great. That's great. Oh, there we go. Nice. Got it. Okay, now we got to simplify this one right here. Now remember, what's going on with this one is really we're dividing this bottom by the top. And instead of dividing, what we're going to do is we're just going to take this bottom right away, this section, and this red section right here. I'm going to flip it and make it into a multiplication on the side. So this is going away, and now we got this is going to be multiplied by x plus 5 divided by x plus 2. And this is gone. Okay? So now instead of doing this multiplication, you just take those, you flip them, and you multiply by the top one. Well, thankfully these are already factored for us, and this one is actually factored for us 2 right here, the x plus 2 there. So we just have to factor this last one right here and simplify things down. I'll do that one in green. Gotta factor this. So we'll take this. Oh, we already factored something just like this. We'll take this 20, and we have the 9. That's 5 and 4, right? So let's just rewrite this all over to the side. First I'll take this x plus 2. That was right. And then I factor the bottom here. This was x plus 5, x plus 4. That was the bottom right there. And then I have x plus 5. And then I have x plus, wait, I'm doing it right. Yeah, x plus 2. X plus 2. Okay, on the bottom. And just everything's being multiplied or divided. We're going to just cancel things out here. This x plus 2 cancels out that, x plus 2 that, x plus 5 cancels out that, x plus 5, and what we're left with is the x plus 4. But remember, it's the denominator. and because it's in the denominator, we have to have something present in the numerator, and that thing that we have to have present is a 1, so we should have 1 over x plus 4 as our final solution. Make sure you use those parentheses there. So we got 1 over x plus 4, and see how I didn't use my parentheses like I said I should, so I'll put those in there right there, and we'll check that out. Things are flowing. Oh, we got another one just like this. Okay, so remember what we're doing. We're going to take this and take this one on the bottom, and we're going to make it into a multiplication, but we're going to flip these two. Okay, so let's just rewrite it up there on top. This will have an x squared plus 6x plus 9, and then on the bottom we have 5x squared plus 15x. 5x squared plus 15x. There we go. And then we'll factor this one in blue, and then we'll factor this bottom one right here in black. But remember, this doesn't exist anymore. We made it into multiplication by flipping it. So let's do each of these sections separately. We'll start on this blue section right here. I got 5x minus 35. I noticed that both of these terms has a factor of 5 in it. So let's pull that out. So I got 5, and then what's left in this x is just an x, and then this is minus 7. When I first took the test, I made that look like a 1, so I got this one wrong. So I got it. You got to slow down. I'm surprised I haven't made a mistake yet. I usually do. And then on the bottom, look at this. We've got a 3x and a 9, and a 3 is to factor both of those. So I'm going to factor out a 3, and I'm left with an x, and I'm left with a 3, so plus 3. So that's the black section right there. Now let's do this red section. We're going to factor that right here. I'll put my 9, my 6. What times what is 9? That adds together to be 6. 3 and 3. X plus 3, x plus 3. And then finally, on the bottom, I got this 5x squared and this 15x. Notice there's a greatest common factor of 5x. So you can pull out of both of those terms. So we'll pull out that 5x. What do we have left here? We just have an x there. And what do we have left here? We have a 3 there. Okay. Now, since everything's factored, we can start canceling top to bottom. Top to bottom. Let's see. X plus 3 cancels that x plus 3. This x plus 3 cancels out that x plus 3. This 5 cancels out this 5. Nothing else cancels out. So what are we left with? We're left with this x minus 7 over 3x. X minus 7 over 3x right there. Let's put that in there. X minus 7 divided by 3x. Ooh. I wonder if I need parentheses. It says to put parentheses. Let's put them in there just in case. Like that, like that. There it is. There it is. Okay, it's going really well right now. We're flying through this thing. We state the domain restrictions for the following ration. Make sure to put commas between all restrictions like this. Okay, so we got 3 comma negative 1. So let's figure out how to do that. The domain restriction is when the bottom is equal to 0. How do we make the bottom equal to 0? Well, first we factor it. So we'll put our little x thing up there, negative 18, and then 3. So what times what is negative 18? That is going to be 3. Oh, 6 and 3, right? And then the 3 is negative. So we have x plus 6, x minus 3. How do we make that 0? Well, this has to be a negative 6, and that has to be a positive 3. So we'll put that in there. So we got negative 6 comma 3. And if you did 3 comma negative 6, that would work too. I have both in there. Both in there. Okay. Oh, let's check. Just make sure I did this right. Yes. It's going well. Okay. Number 11. State the domain restrictions for the following rational equation. So again, we take this x plus 5, this bottom. We're just going to set that equal to 0 to solve. Oh, well, it's already factored. So what is it that makes this bottom equal to 0? It's just negative 5. Negative 5 plus 5 is 0. So put negative 5 in there. That was good. Nice, easy one. Must have those every so often, isn't it? Great. Okay. Oh, here, determine the whole for the rational function. Write your solution in the form x equals a number. For example, you could do x equals 2. Okay, I got it. So to do the whole, we got to factor the top and the bottom. So let's factor this top right here. We got 8 and we got 6. I'm guessing that's 4 and 2. So the top is x plus 4, x plus 2. Okay. Let's factor the bottom. We have negative 8 and negative 2. I'm guessing that's still 4 and 2. But now in this situation, 4 is negative. So we have x minus 4, and then x plus 2, right there. Okay, now here's what a hole is. A hole is what you can cancel. Okay, it's kind of at least what cancels tells you what the hole is. So in this situation, we're going to look at this, and what can we cancel? Oh, I can cancel out this x plus 2 with that x plus 2. Therefore, how do you make this equal to 0? Whatever way you make that equal to 0, that's where the hole is. And you can make this x plus 2 equal to 0 when you make the x equal to -2. So we have a hole when x is equal to -2 there. X equals -2. Great. Okay. Moving on. 2 more problems. There will be 13 problems on the test. I think I cut one out of here. Write the equation of the horizontal asymptote for the rational equation below. Horizontal asymptotes are, just so you guys know, are the form y equals a number. Okay, that's a horizontal asymptote. Same goes for this bottom one, y equals a number. We just got to figure out what that number is. So here's what you want to look for. There's 2 scenarios that we're going to look for. First scenario is when the degree of the numerator is equal to the degree of the denominator, and that's this scenario right here. So what I'm looking at here is, see how 3x has the biggest degree because it's got a good degree of 1, and this x term has the biggest degree because it has a degree of 1, and 1 is also equal to 1, so the degrees are the same. So in this situation, what you do is you take a look at the coefficient in front of the numerator, okay, and you take that coefficient of the largest degree term and put that in a numerator right there. You look at the coefficient of the largest degree term in the denominator. In this situation, nothing in front of that x, but there is. It's a 1. You put that in the denominator here, and here is your horizontal asymptote. So our horizontal asymptote is y is equal to 3. Y is equal to 3. Let's put that in there. Y equals 3. Now I just want to give you one more example, just so I'm clear on this. Let's say I had 4x squared plus 5x minus 3, and then I had 3x squared minus 4. Okay. Now we look at the degree of the numerator and the denominator. This is the largest degree term in the numerator. This is the largest degree term in the denominator because of the 2 there. Okay, that's 2. And look at those 2; they're the same. So we look at the coefficient in front of both those terms. This 4 is the coefficient of this x term, and this 3 is the coefficient of this x term. Thus, our horizontal asymptote in this situation would be 4/3. That's 4 divided by that 3. That's our horizontal asymptote. But that was in this problem. I just want to give you one more situation like that. And so we get y equals 3. Oh, great. One last one to do, then I can be done with this. So here, write the equation of the horizontal asymptote again for the rational equation below. Now, this is second scenario. Second scenario is if the degree of the numerator is less than the degree of the denominator. If that is true, then the horizontal asymptote is automatically defaulted as y equals 0. Okay, so let's just look at the numerator degree. The numerator degree for this one, because of this x is the biggest term, it's a degree of 1. The biggest degree in the denominator is degree 2. Therefore, the numerator degree is less than the denominator degree. Because that is the case, our horizontal asymptote is y equals 0. And the reason that happens is because this thing is so powerful. As this gets bigger, you put a really big number in for the x squared, the rational expression gets closer and closer to 0, but it never gets there. It's kind of a sad scenario. It just never gets there. But it gets close. So we'll check for that. And there you go. That is how you do all these problems on this test. I hope this helps you guys out. I know this is a tough concept. We'll have more time tomorrow. We got to keep chugging away at it. We can't give up on this stuff. Okay? Life isn't always easy. And so we just got to make sure we get back up and work hard and